Welcome to the Drowsy Inquirer. This is a place for calm curiosity. Here, science slows down. There is no urgency, no pressure to keep up, and no expectation to remember everything you hear. Tonight, we're exploring the ocean. Not as a dramatic force, and not as a place of danger, but as a system built on balance, repetition, and quiet consistency. You don't need to focus closely. You can listen actively, or you can let the words fade into the background. Both are perfectly fine. The ocean covers more than 70% of the Earth's surface. Yet most of it has never been directly seen by a human being. Vast regions exist far below the reach of light, where landscapes change slowly, and time behaves differently than it does on land. When we think about the ocean, we often imagine waves, coastlines, or storms. But those familiar images represent only a thin surface layer. Beneath that surface lies a much larger system, organized by temperature, pressure, and depth. The ocean is not a single, uniform body of water. It is layered. Each layer has its own conditions, its own movement patterns, and its own role in maintaining balance. The uppermost layer is the one we interact with most. It is shaped by wind, touched by weather, and constantly changing. This is where sunlight reaches, where waves form, and where most visible marine life exists. But even a short distance below the surface, light begins to fade. Colors disappear one by one, and the environment becomes more stable. Temperatures change more slowly. Movement becomes more predictable. This stability is important. Stable environments allow systems to operate efficiently, without constant disruption. In the ocean, this means that many processes unfold gradually, over long periods of time. Most marine life remains relatively close to the surface. Not because deeper regions are dangerous, but because energy is easier to access near sunlight. Tiny organisms near the surface convert light into usable energy. Those organisms support slightly larger ones, and those, in turn, support larger creatures. Below the sunlit layer, life doesn't disappear. It adapts. Instead of relying on vision, many deep-sea organisms depend on touch, vibration, and subtle changes in pressure. Movement becomes slower. Energy is conserved. Rather than chasing food, many creatures wait, allowing the environment to bring resources to them. This slow pace is one of the defining features of the ocean. Despite its size, very little happens suddenly. Most changes occur gradually, through repetition and long-term adjustment. Even when the surface appears calm, or even still, the ocean beneath is constantly maintaining balance. Tiny shifts in temperature, salinity, and density are always being corrected. This quiet, continuous adjustment is what allows the ocean to remain stable. And it's also what makes thinking about the ocean feel calming. It operates without urgency. It does not rush. It simply responds. Again and again. Over time. One of the most important ways the ocean maintains balance is through movement that is almost impossible to notice. Ocean currents are often imagined as fast, powerful streams of water. In reality, many of the most influential currents move extremely slowly. Some take hundreds, or even thousands of years, to complete a full cycle. These movements are driven by simple physical principles. Warm water rises, cooler water sinks. This constant exchange creates circulation patterns that connect distant regions of the planet. Through these slow currents, heat is distributed across the globe. Warm regions release energy. Cool regions absorb it. The result is a gradual balancing effect that helps regulate Earth's climate. Without the ocean, daily temperature changes on land would be far more extreme. Days would be hotter. Nights would be colder. Seasonal shifts would be more intense. The ocean acts as a buffer, absorbing heat when it is abundant, and releasing it slowly over time. Most of this happens quietly, without visible motion. Another important feature of the ocean is how sound behaves within it. Sound travels much farther in water than it does in air. Because water is denser, sound waves lose less energy as they move. This allows low-frequency sounds to travel across vast distances. Many marine animals rely on sound as their primary way of sensing their environment. Whales, for example, use deep, low-frequency calls that can travel across entire ocean basins. These sounds are not rushed. They are spaced out, measured, and adapted to an environment where consistency matters more than speed. The ocean is also remarkably efficient. Very little is wasted. Organic material sinks, breaks down, and becomes part of the system again. Nutrients are recycled, redistributed, and reused. This continuous process supports life without requiring constant growth or expansion. Instead, it relies on steady circulation and long-term balance. Even the smallest particles play a role. Tiny fragments drift slowly downward, feeding organisms below. Over time, these processes support entire ecosystems without drawing attention to themselves. This efficiency is another reason the ocean feels so stable when we think about it. It doesn't rely on sudden changes. It relies on persistence. As we continue, we'll explore more of these calm processes, one at a time, not rushing forward, and not looking for dramatic moments, but paying attention to the quiet systems that keep the ocean moving, slowly and steadily, through time. As depth increases, pressure becomes one of the ocean's most defining forces. For every 10 meters you descend below the surface, pressure increases steadily. At great depths, this pressure becomes immense, strong enough to crush objects that are not specifically designed to withstand it. Because of this, the deep ocean remains largely untouched. Not because it is dangerous in a dramatic sense, but because it demands patience, careful planning, and precision. In these deeper regions, the environment changes in subtle but important ways. Light disappears completely. Temperatures stabilize. Movement slows down. Without sunlight, the concept of day and night loses meaning. There is no sunrise, no sunset, and no daily rhythm. Instead, time is measured in longer cycles, where changes happen gradually, sometimes over decades or centuries. This absence of rapid change creates a remarkably stable environment. Temperatures fluctuate very little. Currents move gently and predictably. The surroundings remain consistent for long periods of time. Life that exists at these depths adapts to this stability. Energy is conserved. Movement is deliberate. Nothing happens quickly, because nothing needs to. Rather than chasing food, many deep-sea organisms wait. They rely on slow-moving currents to bring nutrients toward them. This strategy reduces effort and increases efficiency. Pressure also influences how organisms are built. Bodies tend to be flexible rather than rigid. Structures are designed to bend instead of resist. This flexibility allows life to exist comfortably in conditions that would otherwise be overwhelming. The deeper the ocean becomes, the more it favors efficiency over speed. Fast reactions are unnecessary. Instead, consistency and endurance become more important. Because change happens so slowly, many deep-sea environments remain largely unchanged for thousands of years. This long-term stability allows ecosystems to function without frequent disruption. From a distance, imagining this environment can feel calming. There is no urgency, no sudden shifts, no constant demand for attention. Everything exists within clear limits, guided by pressure, temperature, and time. The deep ocean does not resist these forces. It adapts to them. And in doing so, it creates a space where balance is maintained through gradual adjustment, rather than sudden reaction. This slow, steady pace is one of the most defining qualities of the ocean. Even though it covers most of the planet, very little within it happens abruptly. Change is always present, but it unfolds quietly, layer by layer, moment by moment, over long stretches of time. And it is this steady rhythm, this lack of urgency, that allows the ocean to remain stable across immense spans of time. Despite its size, the ocean is not a loud place. Away from the surface, there are no crashing waves, no sudden winds, and no sharp disruptions. What exists instead is a form of quiet movement that continues without drawing attention to itself. Water shifts gently. Tiny differences in temperature guide slow currents. Small changes in salinity influence direction and flow. None of these movements are dramatic, but together they shape the entire ocean. In many regions, this movement is so gradual that it becomes almost invisible. There are no clear beginnings or endings, only continuous adjustment. This is how the ocean maintains balance. Rather than reacting strongly to change, it responds with small corrections, made repeatedly over long periods of time. These subtle adjustments redistribute heat, transport nutrients, and maintain equilibrium between distant regions. Nothing happens quickly, but nothing is neglected. Silence plays an important role in this process. Far below the surface, sound behaves differently. Without constant disturbance, the environment remains acoustically stable. In these quiet conditions, movement does not compete for attention. There is no urgency, no need to respond immediately. Everything unfolds according to long-term patterns. Because of this, many oceanic processes rely on persistence rather than speed. A slight shift, repeated over months or years, can eventually reshape entire areas. This slow reshaping is one of the reasons the ocean feels dependable when imagined from a distance. It does not resist change, but it does not rush toward it either. Instead, it allows change to integrate gradually, becoming part of the system rather than disrupting it. Over time, these gentle movements influence where nutrients gather, where life thrives, and where energy is stored. Even the smallest particles contribute. Tiny fragments drift downward, settling slowly through the water. As they descend, they become part of a quiet exchange, feeding organisms below, and supporting life that rarely sees the surface. This process does not require constant input. It does not depend on rapid growth or expansion. It relies on continuity. The ocean adjusts itself through repetition. Small actions, applied consistently, produce stability. This approach contrasts sharply with systems that depend on constant reaction. In the ocean, there is no need to respond immediately to every change. Instead, it absorbs variation and redistributes it slowly. This is why the ocean remains stable. Despite constant movement, change is always present, but it unfolds in measured ways. Nothing is wasted. Nothing is rushed. Everything is accounted for over time. When you think about the ocean in this way, it becomes less mysterious and more reliable. A system that does not demand attention, but still functions continuously. It does not require control. It does not resist its own motion. It simply responds, again and again, through quiet adjustment. This steady rhythm allows the ocean to carry energy, support life, and maintain balance, without ever needing to announce what it is doing. And as these slow processes continue, the ocean remains in motion, not through sudden change, but through consistency. Moment by moment, layer by layer, it moves forward, quietly, and without urgency. Much of the ocean is sustained by a process that happens quietly and almost invisibly. Organic material from the surface slowly drifts downward through the water. Tiny particles, fragments of plants, microscopic organisms, and other remnants descend gradually, forming what scientists often refer to as marine snow. This material does not fall quickly. It moves slowly, sometimes taking weeks or months to reach deeper regions. Along the way, it feeds countless organisms, each one taking only what it needs. This slow descent connects the surface to the depths. Energy captured near sunlight is redistributed downward, supporting life far below. Marine snow is not a dramatic event. There are no sudden drops, no clear start or finish. Instead, it is a continuous process, always happening somewhere in the ocean. Because it moves slowly, it creates stability. Organisms that rely on this material do not need to chase food. They adapt to a steady, predictable supply. This predictability reduces competition. Energy is shared across time, rather than consumed all at once. The result is a system that supports life, without requiring constant disruption. As particles descend, some are consumed, some dissolve, and some reach the ocean floor. Even there, nothing is wasted. On the seabed, these materials become part of a long-term cycle. They are broken down, reused, and incorporated back into the system. This recycling process operates quietly. It does not depend on speed. It depends on continuity. Over long periods, This steady redistribution of energy allows ecosystems to persist in places far removed from the surface. The ocean does not rely on abundance. It relies on balance. Small amounts, delivered consistently, are enough to sustain life. This approach mirrors many of the ocean's processes. Instead of sudden change, it favors repetition. Instead of rapid growth, it favors endurance. Marine snow is one of the clearest examples of how the ocean operates without urgency. It does not rush nutrients downward. It allows them to move at their own pace, integrating gradually into each layer they pass through. When imagined this way, the ocean becomes less about movement and more about flow. A system that feeds itself, not through excess, but through steady circulation. This quiet exchange continues at all times, regardless of weather, season, or surface activity. It does not stop. It does not accelerate. It simply continues, supporting life through consistency. One of the most remarkable qualities of the ocean is how it relates to time. Many of its most important processes unfold over periods that feel distant to human experience. Changes measured in years, decades, or centuries are not unusual in marine systems. Because of this, the ocean rarely reacts quickly. Instead, it absorbs variation and redistributes it gradually. Temperature shifts are moderated. Nutrient changes are spread out. Movement is slowed and softened as it travels through the system. This relationship with time allows the ocean to remain stable, even as conditions change. Rather than resisting variation, it integrates it. Small adjustments, applied repeatedly, can eventually reshape entire regions. But these changes happen quietly, without sharp transitions. The ocean does not hurry toward equilibrium. It allows balance to emerge naturally, through persistence. This long-term perspective is reflected in how marine environments adapt. Instead of frequent disruption, they rely on gradual accommodation. Structures bend rather than break. Systems absorb stress rather than rejecting it. Over time, this creates resilience. From this viewpoint, the ocean appears patient. It does not demand immediate resolution. It allows processes to complete at their own pace. This patience is not passive. It is active consistency, a willingness to continue responding without escalation. Even large-scale changes, such as shifts in circulation patterns, happen incrementally. They unfold slowly enough that the system can adjust along the way. This gradual adaptation prevents sudden collapse. It allows life to reorganize, redistribute, and persist. When we imagine the ocean in this way, it becomes a reminder that stability does not require stillness. Movement can exist without urgency. Change can occur without disruption. The ocean moves forward, not through rapid transformation, but through continuity. Layer by layer, cycle by cycle, it maintains balance by allowing time to do the work. And it is this steady relationship with time that allows the ocean to remain one of the most enduring systems on the planet. Not because it resists change, but because it understands how slowly change truly needs to happen. By this point, it becomes clear that the ocean does not rely on constant novelty. Many of its most important processes repeat, not because they are inefficient, but because repetition creates stability. Patterns form, persist, and quietly reinforce themselves over time. Currents follow familiar paths. Temperatures fluctuate within predictable ranges. Energy moves through cycles that rarely break their rhythm. This repetition allows the ocean to function without supervision. Nothing needs to be monitored closely. Nothing needs immediate correction. Instead, the system remains balanced through continuous, small adjustments. These adjustments are rarely noticeable. They do not announce themselves. They happen gradually, keeping conditions within comfortable limits. From the surface to the deepest regions, this rhythm connects distant parts of the ocean. What happens in one area eventually influences another. Not through sudden force, but through steady transmission. Warm water drifts slowly toward cooler regions. Cooler water sinks and moves elsewhere. Nutrients travel along paths shaped by pressure and temperature. Not urgency. This interconnected movement is one of the ocean's most calming qualities. It shows that balance does not require control, only consistency. The ocean does not need to react dramatically to change. It absorbs variation and redistributes it gently. Because of this, the ocean rarely experiences extremes. Sharp transitions are softened. Sudden shifts are spread out across time. This steady pacing creates reliability. Even when conditions change, they do so slowly enough for the system to adapt. Nothing is forced to respond instantly. Life within the ocean adjusts to this rhythm. Organisms do not rush. They align themselves with patterns that repeat, rather than events that occur once. This alignment reduces stress on the system. Energy is conserved. Resources are shared across time. Instead of being consumed all at once, the ocean does not seek efficiency through speed. It finds efficiency through patience. Small actions, repeated continuously, produce long-term stability. This repetition may seem uneventful, but it is precisely what allows the ocean to endure. Systems built on repetition do not depend on constant input. They sustain themselves through rhythm. As these patterns continue, the ocean moves forward without urgency. There is no sense of hurry. No need to accelerate. Everything progresses at a pace that allows balance to remain intact. And this predictability creates a sense of quiet confidence. The ocean does not surprise itself. It follows paths that have been reinforced over time. And as these paths repeat, they strengthen the system as a whole. This steady repetition is not stagnation. It is maintenance. A continuous process of keeping things within balance. Moment by moment. Cycle by cycle. Without interruption. As this rhythm continues, attention no longer needs to remain focused. Details become less important. Individual ideas do not need to be followed closely. The ocean does not require concentration to exist. It continues whether it is being observed or not. This is one of its quieter lessons. Systems do not depend on attention. They persist through repetition, not awareness. Movement continues beneath the surface. steady and uninterrupted. Currents adjust. Particles drift. Energy circulates. Nothing demands to be noticed. Nothing insists on being understood. Processes unfold regardless of where attention rests. This allows the mind to soften. There is no task to complete. No conclusion waiting to be reached. No sequence that must be remembered. The ocean does not build toward an ending. It maintains itself through continuation. One moment flows into the next, without pause. As attention drifts, the system holds itself together. Balance does not collapse in the absence of focus. It remains intact through structure and repetition. Thoughts may come and go. They do not need to be followed. Like particles in the water, they can drift past without interaction. The ocean offers no resistance to this drifting. It does not pull attention back. It allows space for movement without direction. This permission to let go is built into the system. Nothing requires immediate response. Nothing waits to be solved. The ocean exists within a steady present. Not rushing forward. Not returning backward. But continuing quietly. As this continuation unfolds, it becomes easier to rest within it. The need to analyze fades. The need to track details dissolves. What remains is a sense of ongoing motion. Gentle and consistent. A system that does not depend on effort, but on persistence. The ocean does not correct itself through force. It corrects itself through time. Small variations are absorbed, spread out, and gradually integrated. This allows the system to remain calm, even as it moves. Change is not eliminated. It is softened. As attention drifts further, there is no loss of structure. The rhythm continues, carrying everything forward. Nothing needs to be held on to. Nothing needs to be concluded. The system does not ask for participation. It simply continues. Layer by layer. Moment by moment. Maintaining balance. Without urgency. And without interruption. At this stage, it becomes easier to notice how little the ocean depends on intervention. Most of its balance is maintained. Without correction. Without supervision. And without urgency. Currents continue along familiar paths. Temperature differences are absorbed gradually. Small variations are redistributed before they can become disruptive. This self-regulating behavior is one of the ocean's most important qualities. It does not require constant adjustment. It relies on limits, boundaries that are rarely crossed. Within these limits, movement remains predictable. Change is allowed, but only at a pace the system can accommodate. This is why large-scale shifts in the ocean rarely appear sudden. They develop slowly, layer by layer, often going unnoticed until they are well underway. From the surface, these changes may seem invisible. But beneath, the system is always responding, making small corrections continuously. Nothing waits for permission. Nothing pauses for observation. Processes unfold whether they are being watched or not. This independence allows the ocean to function without drawing attention to itself. It does not signal when adjustments are made. It simply incorporates them into the flow. Because of this, the ocean does not experience overload. Energy is dispersed. Stress is absorbed. Imbalances are softened over time. This softening is important. Rather than reacting sharply, the system bends. Rather than resisting, it redistributes. Over long periods. This approach prevents extremes. Heat does not accumulate in one place. Nutrients do not remain isolated. Movement connects distant regions. Through steady exchange. The result is a system that rarely reaches breaking points. Instead, it remains within tolerable ranges. Even as conditions evolve. This tolerance is not accidental. It emerges from repetition. From the same processes occurring again and again. Refining themselves through consistency. The ocean does not search for optimization. It does not attempt to be faster or more efficient. It simply continues. And through continuation, balance is preserved. As this pattern repeats, it becomes easier to let go of expectation. There is nothing to anticipate. No sudden shift to prepare for. The ocean does not build toward a moment. It maintains itself through ongoing motion. And that ongoing motion, quiet and unannounced, is enough. As the ocean continues in this way, there is no clear point where one process ends and another begins. Boundaries blur. Cycles overlap. Movement transitions smoothly from one pattern into the next. This lack of sharp division is what allows the system to remain uninterrupted. Nothing needs to stop for something else to begin. The ocean does not segment itself. It flows forward through continuity. This continuity makes it easier to release the need for structure. There is no sequence to follow. No order to memorize. Processes exist simultaneously. Each one contributing quietly, without demanding recognition. As attention drifts, the system remains intact. It does not rely on focus. It does not depend on awareness. The ocean continues whether it is understood or not. Whether it is being considered, or simply allowed to exist in the background. This is one of its most calming characteristics. It does not ask anything of the observer. You are not required to track progress. You are not expected to reach conclusions. There is no endpoint waiting ahead. The system maintains itself. Through repetition. Through gentle correction. And through time. Even as individual details fade. The overall rhythm remains. Movement continues. Balance holds. This allows the mind to rest. Without direction. Without evaluation. And without urgency. Thoughts can pass through. Without needing to settle. Attention can loosen. Without consequence. The ocean does not react to this shift. It does not slow down or speed up. It simply continues. Layer by layer. Cycle by cycle. Motion carries forward. Nothing signals completion. Nothing indicates transition. The process remains open. And within that openness, there is space to let go. To allow sound to fade. To allow images to soften. The ocean remains present. Not as a destination, but as an ongoing state. A system that does not conclude, but persists. And as this persistence continues, there is no need to stay with it. It will remain. moving steadily. Whether attention follows or gently drifts away. At this point, the ocean no longer needs to be explained. Its patterns have already been established. Its pace has already been felt. There is nothing new that needs to be added. Movement continues. Not because it is directed, but because it has always been there. Water shifts slowly, guided by forces that do not change quickly. Temperature differences soften. Pressure remains constant. Depth holds everything in place. The ocean does not arrive at conclusions. It does not build toward endings. It continues by repeating what already works. This repetition is not dull. It is stabilizing. Currents follow paths shaped long ago. Particles drift at the same measured pace. Energy circulates without interruption. Nothing requires immediate attention. Nothing needs to be corrected. The system holds itself together through small adjustments made continuously. Even now, far below the surface, movement continues without awareness. It does not wait to be observed. It does not respond to focus. It simply continues. Over long stretches of time, this consistency becomes strength. Change is absorbed, not resisted. Variation is distributed, not concentrated. This is how the ocean remains stable. Not by avoiding motion, but by allowing it to happen slowly. There is no single moment that defines the ocean. No peak. No final state. Only continuation. As attention softens, details become less important. The system does not depend on understanding. It does not require effort. It remains balanced, whether it is being considered or not. Thoughts can pass without direction. Sounds can fade into the background. Nothing needs to be held on to. The ocean does not insist. It does not ask to be followed. It moves forward through persistence alone. Layer by layer. Cycle by cycle. It maintains equilibrium. Without urgency. And this steady movement continues. Long after focus drifts elsewhere. The ocean does not mark time. It does not measure progress. It does not seek completion. It remains in motion. Through quiet repetition. And as this rhythm continues, there is no need to stay alert. No need to remain attentive. The system will continue on its own. Balanced and unchanged by observation. Everything that needs to move will continue moving. Everything that needs to rest will remain still. Nothing is required. The ocean remains steady and uninterrupted, carrying its processes forward. Without effort, without awareness, and without end.